2 to the I equals 2 to the n plus 1 take 2. I'm going to introduce you to another piece of notation. We probably did it a bit last year, but just we write for all n e z plus. Okay, guess what? There's a symbol for that as well. For all, we can just do this. That means for all. And so really, we can just write for all n e z plus. That's math speed. That's what that is. All right. Okay. So we've got the sum of 2i, sum of 2 to the I. So let's first explain what this means. Okay. This means the sum of. That's what that symbol means. That's a summation symbol. And this number down the bottom here is the first value of n. Okay. And this number at the top is the last value of n. So let's put a number here, okay? And at the moment it's n, but let's put a number there and explain what that would mean. If I put the number 3 there, okay? What it would mean 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of 3. Okay? In the question we have an n there, which means we want to go on forever, right? So that's what P of n is. Okay, this is our proposition, that P of n equals 2 to the 1 plus 2 to the 2 plus 2 to the 3. We're doing it for positive integers, that's why we're not including decimals or fractions and so forth, all the way up to 2 to the n. And if we sum that together, the proposition is it equals 2 to the n plus 1, take 2. Okay, should we do it? Yep, let's do it. Okay, so our very first thing is let's test for n equals 1. So we're testing for n equals 1. P of 1, left-hand side will be P of 1, which is 2 to the power of 1. Okay? The right-hand side will be 2 to the 1 plus 1. Therefore, P of 1 is true. Okay, it's true for the first domino. Test for n is 1. Then we're going to assume P of k. And we're going to state what P of k is. It's 2 to the 1 plus 2 to the 2 plus 2 to the 3 plus all the way up to 2 to the k. We're going to assume that P of k equals 2 to the k plus 1, take 2. We're going to assume it's true. So we've stated P of n, a proposition with regards to n. We've tested for the first domino. We've stated our assumption, and now we're ready to move on to the proof. So let's consider P of k plus 1. Now you remember when we first did this, we were like going state, test, assume, prove, explain. Okay, those sort of titles aren't necessary. The steps are what is necessary. Okay, if you want to use them, like you won't be penalised at all. Just by way of tidying it up a bit, making it more orderly. Assume, consider P of k plus 1, which is going to be 2 to the 1 plus 2 to the 2 plus 2 to the k plus 2 to the k plus 1. Okay, it's going to be the next term in the sequence. Alright. Now we can perform the substitution for P of k. What is P of k? This part here. That's P of k. Okay, so let's substitute that for this part here. We've got 2 to the k plus 1, take 2. I'll pause there for a sec. There's P of k, and that's our k plus term. Now here we can see we've got two lots of their like terms, so we can collect them together. If this is A and this is A, we've got two lots of A. So we've got two lots of 2 to the k plus 1. Right, and that gives us 2 times 2 to the base 3. Same base, so we can add the powers, okay? K plus 2. Which is true, all right? Which is, all right, we can see it's true for the k plus 1 term. And so then we'll say because P1 is true, and P of k plus 1 is true, if P of k is true, rule n is equals. Okay, so the strength of stating the proposition means in our explanation we can just refer straight to the proposition, P of n. We don't need to restate it. Okay, so I think we're familiar with the process, right? But maybe we'll just break down another one of the sums. Okay, so let's have a look at C. And let's explain that. Can I write out the left board? So C says the sum from I is 1 of I times 5 to the I T. Okay, so if it helps, again, think about it in terms of numbers. Like let's put a 3 there. Okay, so the first 3 terms are going to be 1 times 5 to the power of 1 plus 2 times 5 to the power of 2. Okay, I'm just substituting from this first value I, and it's for all integers again. From this first value I, so the next integer after 1 is 2, plus 3 times 5 to the 3, plus all the way up to n times 5 to the power of n. Okay, so that's the proposition. P of n is that, which is going to equal, and then we can repeat the process. Let's go down to the product ones and explain that notation. Any questions, sorry, about that one? Excellent. So product 1. I've just stated the question. Alright, so again, the same deal. We start with our first integer here, we substitute that for I. We're going to have 1 take 2 on 1 plus 2. Okay, 1 plus, I'm going to write it out. And then we're going to multiply that by. Okay, we put in the next integer, 1 take 2 on 2 plus 2. We're going to multiply that by 1 take 2 on 3 plus 2. Okay, and so this is the integer that's changing each time, all the way up to 1 take 2 on n plus 2. Okay? Cool. Alright, so I might stop there. You guys can have a bit of a crack. Does anyone want to, should we go? Does anyone want to ask about any of those, or that's okay? Yep. Cool. Thank you.